Hi guys, so today I am just explaining derivatives because why not? Got nothing else to do. So what is a derivative? A derivative is the rate of change of a line on a graph with respect to a variable. Every line graph has a slope and you can find this slope with respect to the variable on the x-axis by taking the derivative. So the variable on the x-axis is just the thing that's on the x-axis, which is the horizontal one. You need to know f of x or y to find the derivative. F of x and y are the same thing. I'll show some notations and stuff before showing the formulae, and you need to memorize these formulae unless you plan on carrying a little notebook everywhere with you, which is what I genuinely do. I do get weird looks, but whatever. F of x and dy by dx. These are the basic notations for first derivative with respect to x. You don't need to know about first derivative, second derivative yet. I might explain that later. There's also df of x by dx, but f of x and y are the exact same thing, which I've already said. All of these ways of writing the first order derivative mean the same thing. Again, you don't need to know about order derivatives yet. What is f of x? F of x is the way of writing a function of x. In the graph to the right, f of x is y. A function is what's happening to x. In this example, f of x is x squared. F of x is x squared because x is being squared. And again, if x were being doubled, then f of x would be 2x, and if x was being added to 5, then f of x would be 5 plus x, and the same for every equation pretty much. Like, if x was being tripled, then f of x would be 3x because we're tripling x. So f of x is just a fancy way of saying, and an easier way of saying, what is happening to x. Straight lines, these are a good place to start when learning about functions. Straight lines are always in the format y equals mx plus c. This can also be said as f of x equals mx plus c if you want to be fancy like that. This image I got it from Wikipedia Commons. It's a great thing. X is the variable on the bottom, m is the derivative in this case, and c is how high up the line is. Remember that y equals f of x. So here you can see that the graph, all the slopes are 0.5 because, that's just the rules. The difference between f of x and f dash of x. The difference is that dash, which is very small but matters a lot, changes the entire equation. F of x is what you do to x to make it y, as I've already said. F dash of x is the derivative of f of x, and if there is more than one function, you can't use f of x and f dash of x for both. So you use more letters like g of x and g dash of x. You can also do h of x, h dash of x, I use the whole alphabet if you need. And you need to know f of x to find f dash of x, but you can probably figure out the pattern by looking at the line, especially if it's a straight line. Well, you do have to have the measurements though. If you don't have the measurements, you can't figure out anything. Basic rules for finding out derivatives. Screenshot this because I am moving on, but you can just Google them, you'll find them. Examples of taking derivative. So if the function is 4x, then f dash of x equals 4 because, they all follow these things, these formulae here. And there are so many more formulae that you will need to know. F of x is 100x plus, I didn't really check the number, 10 million is that? Then f dash of x equals 100 because no matter how much you add to x, if it's not x, then it's just it's the rule. It's the rule here. Why is PowerPoint so complicated? Like, see here, if you put 999, God knows how many nines, that won't matter because there's no x in it. And if f of x just equals x, then f dash of x will equal 1 because, you guys can just look at it by yourself, honestly. Leibniz's notation, dy by dx. D represents delta, which is this little triangle thing, which means change. So it's changing y by changing x, which is the same as f dash of x, which is what Isaac Newton did. That's Isaac Newton's version, because they both made like separate calculus things at the same time, but you guys don't need to know about the history. I don't like this notation as much, but it can be like useful for representing formulae. Again, y is f of x and x is still x. The formulae still apply. You can look at that example there. When will I use this in life? Probably not much. Physics. Velocity is the derivative of position with respect to time, so dy by dx equals position over time. And acceleration is the derivative of velocity with respect to time. Maths. Maths is good. Thanks for watching. God, you can read this.